What happens when you give a robot a brain? Unitree's G1 humanoid just found out, and it's changing everything we thought possible in consumer robotics. But Unitree isn't alone in this race. Lenovo is stepping into the humanoid arena with surprising ambition, and China is preparing to host the first ever Robot Olympics. This isn't just progress, it's a turning point in the evolution of robotics, and it's unfolding right now. The Gamechanging Brain, AMO. So what we're saying was that Unitree's G1 humanoid robot just received a revolutionary upgrade called AMO, or Adaptive Motion Optimization. This isn't just a software update, it's essentially giving the robot a brain that understands how to move like a living being. What makes AMO special? Most humanoid robots struggle with complex movements because controlling 29 degrees of freedom while maintaining balance is incredibly difficult. Traditional approaches used rigid control systems or pre-programmed motions that couldn't adapt to real-world environments. AMO changes everything by combining reinforcement learning with trajectory optimization. The system runs millions of simulations, allowing the robot to fail repeatedly without physical damage. It learns to pick up objects from the floor, reach high shelves, twist its torso, and crouch all without losing balance. These lessons then translate into real-world behavior that works not just in controlled environments, but in your actual home. When you see the G1 bend down to grab a toy, or carefully adjust its balance to place a bottle on a high shelf, that's AMO in action. It's controlling the robot's entire body, legs, torso, waist based on an internal plan, not just isolated joint movements. And it does this in real time, responding to environmental changes and adapting to unpredictable inputs. What's truly remarkable is the teleoperation capability. You can control G1 using a VR headset and it'll mirror your movements. But here's the magic. When you let go, it doesn't freeze. It understands the goal and continues executing the task, smoothly transitioning from human guidance to autonomous action. Under the hood, AMO uses a hybrid motion synthesis pipeline that blends human-like arm movements from motion capture data with sampled torso commands. This generates entirely new kinds of whole-body actions that weren't even in the original datasets. The robot isn't just imitating, it's generalizing. For example, G1 doesn't rely solely on waist motors to tilt its upper body. Instead, it shifts its legs, bends its knees, and uses full-body posture to reach angles that previous robots couldn't attempt. There's extensive work behind the scenes to ensure this control works out of distribution, meaning G1 can handle commands and situations it never encountered during training. In testing, G1 performed tasks like picking up baskets from floor level, walking forward, and placing them on eye-level shelves. This kind of full-body coordination, from crouching to twisting to reaching to placing, used to be science fiction. AMO makes it routine. Now, if you are shocked with this news, make sure to watch how China has already introduced robocops to their public. How does AMO compare to other systems? Coming back, detailed evaluations comparing AMO to older control strategies showed it outperformed everything else across the board. Even when pushed into untrained territory, AMO showed minimal tracking error. In trash-throwing tasks, it smoothly twisted its torso 90 degrees and nailed the throw. In another setup, it picked up a paper bag by aligning its torso, maneuvering its hand through the loop, then lifting and placing it without losing grip or posture. The training process is equally impressive. AMO uses a two-stage learning framework. A teacher policy with access to ideal data, followed by a student policy learning in a more restricted setup, mimicking what the robot would experience in the real world. This approach allows the final system to perform reliably without perfect conditions. The result? G1 with AMO isn't just reacting, it's planning, adjusting, and executing complex tasks that most robots still struggle with. It stretches, crouches, twists, walks, and balances while coordinating all 29 joints across its body. And instead of the mechanical stiffness we usually see in robots, G1's movements feel smooth, deliberate, and surprisingly human. This is where humanoid robotics is heading. Not just mobility, but full-body dexterity with responsiveness that makes real-world deployment finally possible. Unitree didn't stop with humanoids. They've also transformed their B2 quadruped robot into a specialized firefighting machine. This modified version comes equipped with a water or foam cannon capable of shooting up to 60 meters away at 40 liters per second, powerful enough for serious emergency response. The Firefighting B2's joints are upgraded by 170% over the standard model, allowing it to climb obstacles up to 15 inches high and handle steep stairs at a 45-degree angle, perfect for navigating damaged buildings and chaotic disaster scenes. But it's not just about raw power. The B2 firefighting dog is packed with technology, live video feeds, LiDAR sensors, and communication equipment for sending real-time updates to human teams. It features a built-in cooling sprinkler system to survive extreme heat, plus swappable batteries that maintain waterproof integrity. This machine is designed to go where humans can't collapse buildings, toxic environments, zero visibility areas. It can map surroundings, locate fires, carry specialized modules, and support rescue operations without putting human lives at risk. Now, let's switch gears to a surprising new competitor. Lenovo, known primarily for computers and mobile devices, just entered the humanoid robot race with their first model, Lenovo No. 1. At their Tech World 2025 event in Shanghai, Lenovo unveiled this robot with a dramatic demonstration performing a complete Tai Chi routine on stage. This wasn't just walking or standing, but slow, balanced martial arts movements executed live. During the Q&A session, the robot pulled data from Lenovo systems in real time and answered questions like a trained representative. Lenovo isn't just showing off technology, they're planning real-world applications. The company intends to deploy these robots in elder care and healthcare environments soon. And in August, they're bringing Lenovo No. 1 to compete in the Beijing Humanoid Robot Sports Games. Speaking of which, yes, the Robot Olympics is actually happening. Beijing is hosting the first humanoid robot sports games this August at two Olympic venues, the Bird's Nest and the Ice Ribbon. This isn't just a publicity stunt. The event will feature 11 human sports recreated for humanoid robots: track and field, football, gymnastics, and more. Robotics experts and sports professionals have collaborated to create events that mimic human movement as closely as possible. The goal is clear: refine mechanical structure and push motion algorithms further through performance under pressure. This is actually the second major robot sports event in China this year. The first was a humanoid half marathon in April, where 20 robots competed in a 21-kilometer race. One robot, named Kayang Kung Ultra, finished first after nearly 2 hours and 40 minutes. These events aren't just entertainment, they're massive benchmarks for stability, safety, and real-world readiness in complex environments. They serve as testing grounds for robots from different companies, validating their ability to operate outside controlled laboratory settings. Another robot making waves is called Atom, developed by PND Robotics in China. What sets Atom apart is its walking ability. It doesn't just move, it walks like a human, adapting its stride, balance, and pace on uneven terrain. This capability comes from its proprietary reinforcement learning system combined with imitation learning. In development since mid-2023, Atom has seen upgrades to nearly every component. Its legs and feet are reinforced for durability, and the actuators are modular for handling unpredictable environments. Atom runs on a full-stack system powered by an Intel i7 chip with real-time controls and full body motion architecture. It features 25 force-controlled QDD actuators, with legs delivering up to 360 Newton-meters of torque. Looking at all these developments, the direction is clear. We're moving beyond the demonstration phase. These robots aren't just futuristic concepts or experimental prototypes. They're becoming useful tools ready for real-world deployment. The integration of advanced AI with robotics is creating machines that can adapt to our world rather than requiring us to adapt environments for them. From Unitree's AMO Brain to Lenovo's enterprise-focused humanoid to specialized rescue robots, we're seeing practical applications emerge across industries. This isn't just about impressive technology, it's about solving real problems. Firefighting robots can enter dangerous situations without risking human lives. Humanoid assistants could help address labor shortages in healthcare and elder care. And the continuous improvement driven by competitions like the Robot Olympics pushes the entire field forward. We're witnessing the birth of robots that don't just execute pre-programmed tasks, but understand their environments and adapt accordingly. The line between programmed behavior and intelligent action is blurring, making this moment so exciting. So, what do you think? If you had a robot like G1 or Atom at home, what would be the first task you'd have it do? Let me know in the comments below. Thanks for watching, and I'll see you in the next video.